Vista's modern approach to engineering can really be best compared to the way we consume news. Traditionally, we would receive newspapers. I grew up in St. Albert, and so we typically would get a newspaper every Sunday morning, and it would tell us about what happened in the last week and what was happening in the following week. That used to be good enough. But now the news we consume needs to be up to date. We expect up to the minute, and if something's 2, 3, 4, 5 hours old, it's out of date, and we're going to look for something newer. And that's exactly the same philosophy that we bring to the table with our engineering execution. Hi, my name is Scott Moosbacher, the Systems Integration Lead here at Vista Projects. Today I've got a presentation to talk to you about digitally enabled and data-centric project execution. In the traditional engineering approach, we relied on lagging indicators to make decisions. So our piping model was only used for graphics. We had MTOs that were generated manually and took a long time to develop. And our deliverables were generally developed on paper. We had a lot of spreadsheets that tracked everything, and we did a great job tracking them. So good, in fact, that we had spreadsheets that tracked other spreadsheets. So as you can imagine, to do that and to develop those high quality engineering deliverables took a little bit of extra cost during the engineering phase. This was offset, though, by reductions in construction, because we often had reduced amounts of requests for clarifications during the construction phase, which meant that the construction teams weren't stuck on problems that needed solutions. Now, in Vista's data-centric execution, what we've done is we've maintained that high quality of engineering deliverables that our customers and clients have grown accustomed to with Vista, and we've automated a lot of that. How we've done that is we've done all of our engineering execution in databases. And so really it's a data-centric execution approach. Our deliverables are no longer developed independently. What our deliverables are, like our line lists and our P&IDs, are all reports coming straight from this database. And what this does is it significantly enhances the ease of adapting to change throughout a project. When we need to make changes to our systems or changes to the process, we can leverage our tools to identify what needs to get changed so that our engineers are focused on what exactly needs to change rather than trying to figure out what deliverables this change might impact. Now, the way we execute digitally enabled and data-centric projects is by developing a digital twin of our project. A lot of people talk about what digital twins are, but I'd like to tell you a little bit more about how Vista defines our digital twin. For every physical asset that we design, there's a digital asset that comes along with it. So for example, if we've got an exchanger module that you see on the screen there, physically it exists in the field, but digitally it exists in a 3D model. Information exists in multiple different spaces and places for that asset. And here's what I mean. Our digital asset is comprised of 3 different components from our perspective: our 1D, our 2D, and our 3D assets. In our 1D assets, we've got our data sheets, we've got our line lists, mechanical equipment lists, and other lists of objects. Our 2D assets are our drawings, like our P&IDs, our shop drawings, our isometrics, and our 3D is our 3D model and our laser scans. Combined together, those form the full digital twin, not just a 3D model of something. We're able to use our 1D, 2D, and 3D components to be able to develop a digital twin for our facility, which is especially valuable during our project execution, as well as for our downstream users. So what this enables is it increases our transparency and our collaboration. Our transparency is increased because we allow instant access to real-time data to all stakeholders in the project, whether that's internal to Vista or to our clients. When all that information is readily accessible and available, it really enhances the collaboration, especially when you're dealing with real-time data. For example, historically, when we used to deal with P&ID stick files, the stick file would be sitting in a remote corner of the office, and it would rely on engineers and designers to physically go and mark up the tool. Typically, there was only room for one person to go do that. And so what you ended up with was infrequent updates, and the P&ID stick file, which was supposed to be the single source of truth, was historically outdated and not up to speed. Now, with our digital tools in place, we have digital stick files files that enable everyone to collaboratively add markups to this P90 stick file in real time and see actively what every other discipline is doing at the same time. This allows for better decision making because you're not making decisions based on historical data, you're making decisions based on what's going on today. With increased quality, because we're so collaborative, we're able to use these tools as well to leverage their capability to do comparisons. A great example of this is in our on our P90s and our line lists. Historically, what we would do is we would have a P90 and a line list lined up against each other. We would do a yellow off to compare to make sure that everything was succinct. Now with our digital tools and our database style execution philosophy, our systems integration team has been able to leverage the tool to be able to identify when there are assets that are out of sync with each other. For example, if your insulation thickness or your line number or your line size has changed on one of the tools, our system identifies that there's been a change that is no longer in sync with the other native tools. What this allows is that it enables our engineers to really focus on making those changes rather than trying to find where those changes might be. Now, this leads to obviously enhanced quality, and with enhanced quality, it then translates to reduced cost during construction. One of the biggest factors for request for clarification out of the field is when two sets of data don't line up. Because we've leveraged our tools to ensure that everything going to our clients is 100% in sync, we no longer have these requests for clarifications that cause delays in the construction and increase construction costs. In addition, when we have changes that we need to make to the P90s or to the LDTs or any other of the deliverables that we develop in our data execution model, we're able to readily identify what needs to change and what associated deliverables needs to change along the way. It also enables us to reduce the risks associated with it and to do rapid replication of similar projects. Rather than copying and pasting the end product, what we're able to do is we're able to copy and paste the foundational data. We never do the exact same application over and over, but what we do is we make sure that we pull in the data to ensure that the replication is done right. What this results in is a lower installed cost for your projects with a faster and accelerated execution plan. Not only does a data-centric engineering execution philosophy result in savings during the project, but it also has a lot of post-construction and operational data benefits as well. When we turn over our projects, no longer are we sending over 2 U-Hauls of binders with paper-based data and information. Instead, what we turn over is a technical data portal that is easily searchable and extremely cross-referenced so that you can have access to any information that you need within a few clicks of a mouse. The technical data portal also provides ease of access to all this information, and it's the single source of truth. And when you go to our technical data portal that you're getting the latest and greatest information and not historical data. So let's talk a little bit about this technical data portal. There is a ton of information that we put into this technical data portal that's easily accessible and readily available when you need it. So our technical data portal combines information from multiple different source tools and combines it into a single website that can be accessed by anyone. So for example, on an engineering program, we have all of our engineering data completed in one spot. Our P90s are completed in another native tool, our 3D model in another tool, and our other disciplines are completed in a different tool. What our technical data portal does is it pulls all that information together and is capable of analyzing it and ensuring that particular assets can be directly compared to each other. And so what this technical data portal can do is it not only can display data and documents, but it can function as a comparison tool that you can use for ongoing analysis of your facility. Another advantage of our technical data portal is the way that information is accessed and conveyed to different people on the project. Typically, the way it works is the engineers and designers and support staff complete the work, it's sent up through our sub-leads and our leads, and it's filtered along the way to our project manager, and finally gets to our client project engineer. Instead, in our technical data portal, we have our client that's able to directly access the raw data and what Vista is doing. For example, on a recent project, we took the steel that was being modeled on a daily basis and extracted it directly from the database so that our client could visualize how much steel was being modeled on a daily basis and compare it to his final estimate that he was expecting. Another example is that we were able to pull piping MTOs every single day from our model so that we could get key quantity indicators of where that facility was going with respect to cost and price. Our technical data portal isn't just confined to engineering documentation and data, though. It can be expanded and can access historical documents and data, contracts, operation and maintenance data, completions data, materials management tracking, whatever you feel that you need for your particular project. We can ensure that it's incorporated into the technical data portal so that it's all available via a single access portal. The other advantage of the technical data portal after you've finished your project's execution is that you've got a tool that can be used for the lifetime of the facility. Now, instead of having to go and find documents and data in binders that are only physically existing in one spot, the technical data portal can be leveraged by a full suite of stakeholders in your organization that might need access to the particular asset. For example, during startup, you might need your CS&U team to be able to access information on a pump, or during your maintenance operations, you want to have your maintenance team have full access to all the information on that pump, the maintenance records, the data sheets, the servicing that's been completed, and all that can be compiled into this digital twin. So not only is this providing a lot of value throughout the project, but there's infinite more value once you actually get into the operations of your facility. Let us know if you have any questions. We're always happy to talk about how we can help out on your project.